So students, for writing IUPAC name, okay, as you know that carbon has a 4 valency, okay, that's why it is called as a tetravalent, okay. So whenever we have to attach, okay, mainly it is attached with the hydrogen, okay, it readily attached with the hydrogen of one, okay. So if we have to satisfy its valency, okay, we can write from iodine, one molecule of iodine, one bromine, one chlorine, one hydrogen, and it has a 4, 1 2 3 4. So it is satisfy valency, okay. In the form of C2H4 you write here, okay, in C, carbon carbon bond, double bond is here, okay. So 2 3 4, so its valency also satisfied, it is attached with the 1 2 3 4, okay, 1 2 3 4, okay. So this is satisfaction of this valency, okay. So this is the first main thing, okay. In previous session, okay, what we talk about the alkane, their general formula and their common name, you have to understand, then you have to understand the two just balance of the carbon, okay. So if carbon is well balanced, so you can easily do it. And in last chapter also, last week also, we discuss about it, okay. When one carbon is removed from methane, okay, we called it meth. Two carbon eth, okay, two carbon is there. When only one carbon, we said it meth. Two carbon in the formula of a compound, we called it as eth. Third prop, four bute, five pent. I hope you understand them, okay, you already read it. 6 for hex, okay. 7 carbon compound is there, hapt. 8 carbon compound ox, okay. 9 non. 10 deck. 11 undeck. 12 two deck, okay. Further you have to not understand till 9, you have to read or understand, okay. Till 9 you have to memorize, or 10 deca you understand easily, okay. So till 9 you have to understand that if we talk about the 7 carbon compound, if there is a chain, okay, containing 7 like that, so it means in this formula have to will become, okay. How it will done, I will explain. So if the example we take here, okay, we write it here CH3, okay. Just write anything you can write by yourself, okay. CH, first write only, if I just share it, okay, make here only 1 2 3 4, okay. So you have to satisfy them, okay. So carbon has one valency here, in last year is CH3, okay. Here 1 2, okay. So you have to write CH2 here, okay, CH and CH3 like that, okay. When you make it, okay, so when we see here double bond is present here, okay. In your book also given this was, okay, butene, okay. And this is the structure of second one. You can see here that ch2 ch2 ch double bond ch2 ch3 ch double bond ch ch3, okay. So in this you can see this is the formula of 4 carbon is present here, 1 2 3 4, from any side, okay, from left hand side or right hand side you can calculate, but you have to calculate from the side from which the bond is nearest, okay. So here double bond is nearest from this chain, okay. So we read from here, okay, 1 2 3 4, 4 carbon is there, okay. So we write it as a but 1 in, okay, because the carbon is in only one is here, okay. So no need to write 1, okay. We never write 1, okay, when there is only one carbon is here, so we write it as a butane, okay. But it's come in the form of IUPAC, you have to write but 1 in, okay, because it's a double bond here, it is the form of in, okay. So same as here but 2 in, okay, because carbon is the second position. So you can see here their molecular formula is same, if you count them 1 2 3 4 C4 and H3 2 1 2, it becomes the 8 C4H8. So their molecular formula is same C4H8 for this also, but their position is something different, okay. Carbon is attached here in carbon is formed double bond here in first position and here in second position, so that's why we call them in the position isomers, okay. When you read, and these type of compounds exhibit isomerism, okay. So when you read about the isomerism you will definitely understand it well, okay. So here the condition structural formula is different. Okay, and other thing which you have to understand, okay, these are the subunits. Okay, subunits you can take a screenshot or you can understand them. Okay, methyl, ethyl, chloro, bromo, iodo, fluoro, mainly these are the thing. Nitro sometime when you are going to writing the IUPAC name. Okay, so this is the longest when we talk about the writing IUPAC name. First thing is that we have to find the longest carbon carbon chain. Okay, so in this uh, example of butane, okay, this is one single carbon chain, longest carbon chain we find first. Okay, now we can go from either side in this because only single bond is present there. You can write from left hand side also, right hand side also. Okay, so we write it 1 2, mainly left hand side will be preferable. Okay, 1 2 3 4. Okay, it is 1 2 3 4, 4 is here, it means but. Okay, and a single carbon bond is here, so it is in. Okay, it is alkane, it is a single bond here, so we write it as butane. Okay, so that was easy to writing a IUPAC name. Suppose there is a, now you can see here CS3 is attached here. Okay, CS3 means it is a sub uh, sub if you say that subunit. Okay, or substituents. Okay, so CS3 is here. So from here the 2 methyl propane, we can write it as a 2 methyl because the carbon this sub unit is present in the second position here. Okay, if you write it here from 1 2 3, because longest carbon chain is this. Okay, first you have to identify longest carbon chain. When you read the rules to write IUPAC name, first rule is that, okay, longest carbon chain you have to find. Longest carbon chain is 3. Okay, this was carbon chain longest from here. Okay, from, if you talk here, here only 2, here also 3 carbon, we can write it here from here or any, it is the longest chain. So we can give their name from any side, 1 2 3 1 2 3. Okay, preferable is left hand side. So when we go from left hand side, one carbon is here, second is here, and a methyl group is attached here. Okay, so what we called it as a 2 methyl propane because 1 2 3, 3 means pro. Okay, so it we sorry, 4 is it a 1 2 3 4, 4 is means it is a prop. Okay, so sorry, 3 is the longest chain is 3, so it is become the propane. Okay, it has single structure here also, so it is a propane. Okay, so this is the sub about the subunit. Okay, so when you see their formula also, okay, C4H10 is here also, here is C4H10 also, but their structure is different, so they are also isomers. Okay, so this is the concept of isomers which you have to clear in the form of IUPAC name also. Now another example we can take. Okay, if we take this much long carbon chain, okay, in which 7 carbon compound is found, 1 2 3 4 5 6 7. Okay, and a methyl group is attached. It is very interesting, see here in the fourth one position and here is third one position. Okay, so these are the substituents. Okay, methyl and 2 substituents are here. So first what we have to do, we have to come with the shortest position first. Okay, this is the longest chain we find, this first thing we do, longest chain, then we come to the nearest one. Okay, nearest one subunit or group is here. From here when we move from right hand side, because from here it comes to fourth position. Okay, so we move to the from right hand side. Okay, what we can write, 1 2 3, 3 first we write, comma we have to put, then in fourth position, okay, another group is here. When same groups are present, same groups are present here, so what we can write then, di, in the form of di, because di means 2. So di, methyl is here, subunit is methyl. Okay, or substance is methyl, so it's become the sub dimethyl. Okay, so 7 carbon is here, so it is in 7. Heptene means it become the single carbon chain, it means become the alkane, we write it as a heptane, 3 4 dimethyl heptane. And students, whenever if in exam writing a IUPAC name come, you have to keep in mind, don't forget to put comma, okay, before 2 subsequent chain. Okay, 3 4 is there, and then if you write starting name, you have to put a dash. Okay, like this. Suppose there are different thing. Okay, two other groups are attached. Okay, two different groups are attached. One is bromo, one is chloro. Okay, in the first one example, two methyl groups are attached, but here one bromo is chloro attached. What we do? Now we go alphabetically. Okay, so you can see longest carbon chain is like this. Okay, 1 2 3 4, and we can start from anywhere because in 1 2 3 1 2 3 4, but as we have to go alphabetically, so bromo B is coming first. Okay, so in the second position is attached bromo, here bromine is attached. Okay, so we write it as 2 bromo 3 chloro and ane, because it is a single carbon, so it is become butane. Okay, because you have to understand carefully these things. That's why I already explained you the about the substituent. Okay, these are the substituents and written as bromo, chloro, iodo, and methyl. Okay, ethyl, like that. Now the main thing is coming. Okay, which is the base, or you can say the boss of the all things of IUPAC names. Okay, functional groups. Okay, so these are the these decide the property of compound. These functional group. Okay, whatever chemical properties is found in any compound, these decided by the these functional group. These are alcohol, aldehyde, ketone, carboxylic acid. And whenever you have to write the IUPAC name for a alcohol compound, you write it as a form of all. Okay, aldehyde as the form of L. Okay, Al, and ketone on, and carboxylic acid oic acid. Okay, some other form also found, ether and ester. We will discuss about them later. Okay, now first thing you have to understand what is the priority. Okay, first priority to count the carbon chain, okay, is from functional group. Whenever functional group is, we see the functional group, first we have to start with it, then come the double bond, or triple bond. Okay, then come the substituent. Okay, to count the number of carbon atom in a carbon chain. Suppose the example is taken here. Okay, cs3 ch cs3oh. Okay, then here is functional group present, so we have to start the chain which is nearest to the functional group. Here is only 3, so you can easily do it. Okay, so what we have to do, 1 2 3, it means 3 carbon, it means it come in the form of prop. Okay, prop. So alcohol is attached, so we can write it as in the IUPAC name prope to all, because the all is present in the form of second position. Okay, propane to all is become, because E is the vowel, after that is vowel come, so we have to remove this E. Okay, so we write it as a propanol only. Okay, understood or not this thing? Because you have to understand this, why we removed one E, because after that vowel should become. Okay, that's why we have to remove E here. Then if you see other examples, okay, cs3 cs2h, it is the example of ethyl alcohol mainly. Okay, if exam it like this position come, you have to write its IUPAC name. So you started from the first, because functional group is attached in the first carbon, we started from first here. Okay, then we move to the second. So what we write it as, because the first carbon is there, ethane, one all. Okay, it is the ethane, because there are two carbon only, so we can write it as ethane. Okay, and the carbon position and the position of functional group attached to carbon is first one, so it becomes all. Okay, so what we can write it as, ethanol. Okay, as the vowel come after that, so we have to remove E, ethanol. Okay, same thing for the butane also. Okay, we can write it there butane, one another example. Okay, so it is the butane to all. Okay, like this you can do other examples also. Okay, for aldehyde, if you have to write aldehyde, you can see here CHO. Okay, this is the chain structure. Okay, so the example, one thing what I want to discuss with you, the difference between the groups, these ketone and aldehyde. It's so confusing whenever CO bond is present. Okay, it is the ketone and CHO is aldehyde. So you can see here, whenever H is present nearer to this carbon, it means it is a aldehyde. When there no carbon in its chain, okay, something other, or one carbon or other things, other group is present. Okay, so we call it a ketone. Okay, because the return is same as CO is also CO also, but you can find that hydrogen is present in the chain of aldehyde, okay, and in the chain of ketone is not present, okay, hydrogen. This is the difference. So when we write, suppose there is an example, okay, CHO, but we write it as ethanol, okay, because the hydrogen is present, it means it is a aldehyde, okay, so we can write it as a methanol, okay. And from ketone example, okay, CS3, you can see here hydrogen is not attached, two methyl groups are there, okay, CS3 and CS3. So here O only, so 3 carbon is there, 1 2 3, so we can write it as propane 2 on, because on is present in the second position, okay, from the formula of ketone, okay, the group is present is there ketone, so we can write it as a propane 2 on. So these are the some examples of these, okay.